Now you'll remember that the kernels of the top coils of the IF cans were stuck. And actually, no matter how much force I exerted on those kernels, they were simply not releasing. I also tried to release them with a little bit of heat and a little bit of acetone. No way, it didn't work. So I ended up cutting off the part of the tube where the kernel is sat. And here it is. And if I examine the surface of it, then it certainly looks like glue has been used on it. So what I'll need to do is to clean the kernel off as well as I can, and then replace it into a tube. And I will need to find, or cut if you wish, excuse me, a new tube which fits exactly on top of this tube, and which is perhaps a little bit more giving than this tube, because the plastic has really aged, and owing not only to the age of it and the brittleness of it, but also to the glue they used to glue fast this kernel, well, it has decayed. So I will have to replace the piece of broken tube. You see the tube there. Well, I'll have to find something similar to replace the part which is missing now. Anyway, I'm glad I finally released the kernel without breaking it, because breaking a kernel like this is really hellish, because it's very hard to find replacements. So I'm in the process now of doing the same thing to the other tube. So I'm gently cutting away parts of the tube, the upper tube you see here, where the kernel is stuck. And once I've freed most of the kernel, with a little bit of gentle persuasion, I can screw it out and then remove the final little parts of the upper part of the tube. And then I'll do the same thing I'll do on this one. I'll replace it by using a new piece of tubing. So you can judge for yourselves that it's not so easy to cut off part of the upper part of the IF coil assembly, or rather the tubing. And unfortunately I broke off a tiny little piece of the kernel, but it's not really a problem because it's a clean break, so I can use a tiny little bit of super glue gel to glue it back to the top of the kernel. So that's really not a problem. What is a problem is that this kernel, this one over here in other words, is just as stuck in glue as was the other one. So it's really slow going, because I want to avoid at any cost any more damage to the thing. So okay, well, let's get on with it. I think I've said it already in the past, that if you decide to work on an IF coil, well, it's not a job for the faint of heart, because IF coils are really quite delicate actually, and they can easily break. By the way, I succeeded in releasing both kernels from of both IF coil assemblies. So I'm giving them a cleaning bath in pure clean acetone, and by the way in a metal can, because acetone will dissolve plastic, and we don't want dissolved plastic on the kernels. So back to the coil. Well, obviously, well, it was bound to happen, but apparently the assembly tube was already weakened at its base, and the base broke. So I'll need to repair the IF coil tube base too, unfortunately. But you know, it happens. And anyway, the plastic that forms the IF coil assembly is really brittle and old already. So it was actually just a matter of time for it to happen. Anyway, I needed to release those kernels, those graphite kernels, because if I can't make them turn properly inside the coil assemblies, I'll never be able to align the radio. So that's it for the moment. On with the next job, namely repairing the IF coil assembly, repairing the kernels, and then replacing, if necessary, the top parts of the tubings before I reinsert the kernel. Orion. Now, as as you can see, I managed to stabilize the IF tubes, you could say, on which the coils are mounted, and which is a good thing because they were rather weak. But with the use of a tiny little drop of super glue gel to attach them in the right position, and then using some fast setting epoxy glue, I managed to mount them correctly back into their position, which is nice. But I still have to repair one of the wires of the one IF coil you see down there. Let me take a pointer. So down there, and I think you can hardly see it, but you see that little wire here needs to be repaired because it broke, unfortunately. Now it may seem like undoable, but I have a trick up my sleeve, and the trick is this. I took a tiny little piece of wire which I bent into a pigtail, as you can see, and I'm going to slide the end you see there, this little end, into the pigtail, and then use a tiny little drop of solder to solder this end of the wire inside the pigtail. Now you can see the pigtail has one straight end. That end I will use to solder it to that little foot over there, yeah, and that way I will hopefully repair this IF coil. Now I don't think it'll be a problem as long as I can make a good contact between the pigtail and the end of wire you see here. Now it might seem a bit problematic, but I think I can do it. And once I've done it, I'll show you the result. And when that is done, then I still need to reconnect a wire on the other side of the upper IF coil. And when that is done, then the whole IF coil is functional again, I hope. But I'm fairly confident it will be So measurements will show whether I succeeded or not. So here we go. And there you go, the little pigtail attached over the wire. Now, what I did actually was gently roll the leftover wire between my thumb and my index like this until it formed a nice little straight wire, which I threaded into the pigtail you see over there. Once it was threaded into the pigtail, I dripped some very hot and very fine solder. In fact, I dripped this kind of solder, which you see, which is very thin and which has rosin inside of its core. So I used very, very fine grade solder. And as you can see, it worked out just nice. Now, the proof of the pudding, of course, is, did it work? Well, I connected my multimeter with one crocodile clamp to one end of the repaired IF coil, and now I'm going to clamp this to the other end. Okay, so now let's see. Okay, here we go. So you see it's measuring infinity right now. So here we go. There you go. And there you go. It measures very little resistance. Well, in fact, let's see. This scale is the 20 ohm scale. And as you can see, it measures about 12 ohms, which is consistent with the resistance a high frequency spool should have. So, that part of the repair succeeded. Now, the next thing I need to do is to reconnect the little end of the pigtail to the right contact, which you see right next to the white crocodile clamp, so that little contact down there, and then measure it again. And when that is done, then I need to reconnect the other wire. But at least until now, it seems the operation succeeded. So onward. No, I haven't repaired the tubes of the IF cores just yet. You know, the little ends up here and over here. So actually, no, you could say that the kernels are still floating a bit around in the air, you could say. Anyway, I've been trying to align the radio in the AM band, which is the middle button, this one. And well, I'll show you as far as I have gotten until now. Okay, let's switch on the radio. You see, the pilot light is on. Well, and there is the alignment signal. And you can hear it's quite clear. So I'm pumping it into the circuit via the yellow crocodile clamp, and the yellow crocodile clamp is attached to my RF generator, which you see over there. And if you look closely, if you look closely at the dial, you'll see that I set 455 kilohertz, you know, which is the B band you see over there. So I don't know, wait, let me show you like this. So you can see that I set it on 455 kilohertz. Now, it's all good and well that I have an alignment signal coming through the radio. It doesn't seem to do a lot. In fact, it does nothing. Nothing at all, because if I uncouple, there you go. If I uncouple the IF signal or alignment signal, that's about the only thing I hear. A sort of an angry growling coming from the radio. No matter where I tune the radio or to what I tune the radio, all I'm getting is either nothing or a very angry, ugly sound, like you can hear right now. So there's obviously something still very wrong with the radio. I don't know what it is, but well, obviously I'm going to keep on looking for the source of the problem. Now, in my opinion, there can be several problems. Either the tuning capacitor is still a bit off, or maybe even the plates are touching still. I don't know. I need to check that. It could be that something is wrong with the local oscillator. Maybe. The trouble is, though, that I don't have alignment instructions for this radio. And no matter how hard I looked around on the internet, I just couldn't find any alignment instructions, which is a pretty damn big nuisance. So I'm a little bit reduced at trying a alignment procedure which I used for one of my other radios, which was Westinghouse. Now obviously Westinghouse and Orion are not the same brand, so I'm fairly certain that the alignment instructions for the Westinghouse are not exactly the ones I should use on this radio. But hey, for the moment, that's all I have to get by. So, yeah, I still have some work to do on the Orion chassis. So, okay, back to the Orion chassis. Now, you remember that I wasn't getting anything out of the chassis except for some very ugly noise. Now I've moved on a bit from there, and well, as you can see, it's on, but I'm only getting a slight hum. Now listen what happens when I inject an antenna signal straight into the circuit. Yes, German radio station, and on the AM band, the middle button you see here. It's still very faint, but at least it proves to me that the radio does work. Now, unfortunately for me, when I connect up the antenna to the antenna input, then I get no signal whatsoever. So, as you can see, it's connected to a long wire, and the wire is tapped into the circuitry of the radio via a short crocodile lead. Now, the place where I tapped it in, I'll show you next on the schematic. Okay, and here is the schematic of the Orion. Now, the place where I'm tapping in the antenna signal is where the cursor is pointing at. So right here, actually, yeah. So this pin here, or alternatively, I can connect it up to this pin there, pin 7 on the schematic. So either pin 5 or pin 7 will inject a kind of a signal into the radio. Now you'll say, okay, how's that possible? Because the circuitry is open here. Well, actually, these connections are connected up to the AM band. Yeah. So I think that shouldn't pose a problem, in other words, So anyway, the signal finds its way down into the high frequency detector tube, which is the ECH81. So eventually the signal finds a path down into the detector tube, which you see here. And as it passes through the tube, it passes through the whole circuitry, and in the end, that's what we hear. Yes, it's still very faint, but no matter. Now that I know that the radio functions, basically, I need to find where there is a circuit interruption between the antenna input and the rest of the circuitry. Once I find that, I can move on and start to truly finish the radio chassis. Just in case you thought that the problem of the chassis would be the output stage or the amplification stage of the chassis, well, here's the proof it isn't. Loud, isn't it? Well, I'm injecting a low frequency signal straight into the amplification circuit, as you can see right there, and well, it's loud. It's really loud. So the amplification circuit works just fine. So what I really need to do to solve the problem is find well, what's the matter with the high frequency circuit. Now I have to say that the one of the plates of one of the high frequency tubes is, well, kind of running hot. So I will have to find a way to find whatever is the problem in the high frequency part of the chassis. But as you can hear, the low frequency part works just fine.